Anybody with questions on yesterday? Hmm? Nobody? You understood tides and what is the tide exactly and how it affects us? The most important factor that affects you is always the tide on ships. Hmm. Clear for everyone? Yes, no.
Yes, sir.
Very good. Now let us move on wind. Okay. It's a very strange thing, no? Uh, we get wind for variety of reasons. Okay. Basically, the wind gets formed because uneven heating of the Earth's surface. Like land gets heated up faster. Out of that, also, you will find rock gets heated up faster, and so on. There are varieties. Seawater or any water body. You must have noticed it also during summer vacations and all. You go somewhere and then you have got a lake or something, and you realize how cold is the water. Now, of course, I'm just brushing it up again for you all. Uh, the heat that we receive from the sun cannot penetrate deep in on land. It will just penetrate maybe about say 15-20 centimeters, maybe, or maybe little more 30 centimeters. That's it. So it gives up all the heat in that layer only. That is why land gets heated up faster, and it gets cooled also faster. Whereas what happens, the sun's rays, the water is not opaque like land. So sun's ray go deeper, means they reach maybe 1.5 kilometer down. So then they disperse the heat, which is going in on a huge volume. So it doesn't get heated up that much. So seawater impact is very low of the, you have always bright sun, everything okay, but the water temperatures don't really go up and down like what happens on the land. Now what happens is, all over the globe we have got air. Now some place air is in contact with say land, which is getting heated up, so the air gets the heat. Air is not getting directly heated up by the sun's rays radiation. It is getting heated up by conduction, convection and all those things, but not directly radiation. It is something like seawater only or water. The rays pass through. They don't really heat up anything except minute amounts here and there. But when the air is in touch with a hot land, it gets heated up. Now, when it gets heated up, it gets lighter, so it rises. When it rises, a vacuum gets created, and that must be filled up. So, nearby area sends that air here, and that is what we call wind. Now, winds are not straightforward, like they really don't travel straightforward. There is a low pressure here, high pressure here, it travels straight. No, it goes at certain angle and all that you will be studying in meteorology. Okay, you will be studying how the wind directions are there and why there are certain wind directions in the northern hemisphere. What is the rotational movement of the wind around the high pressure area or low pressure area. So this is all for meteorology. All we know is there is wind, and wind has got the speed also. There is a force involved in it. So there are few things you have to remember. Wind, the strength is generally measured on a Beaufort scale. There is a scale Beaufort, Beaufort, Beaufort scale. And what happens is, earlier days we did not have anemometers to measure it more accurately. So how we were judging the wind speed. Direction, okay, you put your hand whenever the wind is going in your sleeve, that is the relative direction of the wind. But if I want to know the speed of it and I don't have anything to measure it, there used to be problems. So what happened was, somewhere it was found, okay, if wind speed is between this and this, the sea condition will be like this. Means there will be rippled seas, or how many waves are breaking. Then you take a unit area and say how many waves are breaking there. Okay, if this is the case, then I compare it with a picture. I take a picture in hand, look at it. I look at the sea condition, and I judge this is the force of the wind. This is how we measure it on Beaufort scale. Okay, normally the ships travel at a speed of approximately say 35-40 kilometers per hour. That means the relative wind, when there is no wind at all, relative wind will be 35 kilometers per hour. It is quite lot. If you ride motorcycles, you have got idea what I'm talking about. And suppose you have got also about 35 uh, kilometers per hour wind in a natural way, and it is opposite. So that means you are facing actually something like 65-70 kilometers per hour wind force. Now what happens? The ship is designed with certain aerodynamic and all, and then hydrodynamics and all, to create a minimum resistance. But our biggest problem is accommodation block. It is a building you have put, so it creates turbulence. It acts as a sail sometimes, but it blocks maximum, so it creates a big resistance. So that is what starts hampering our speed. Why? Because something is getting dragged in front or from sides, so it starts acting like a sail, and it affects your speed. The speed can be affected quite drastically, just by strong wind. And if the strong wind is also going to create waves, the waves will be created. Why? Because wind is blowing like this, so water will also start following waves will be created. Now, one important thing you must remember about wind never has a constant velocity, never has. There will be some velocity, then there will be burst of high speed winds, which we call gusts. The frequency of gusts will depend on the situation. And then there are strong winds which get generated for a longer period, like about 1 minute and all. Then we call gust is called squall. Gust is few seconds. Squall is like it will last for 1 minute. And then if the wind force is stronger, like what we say first is the calm sea, then we say light wind. Light wind is there is some wind and all, means you don't feel sweaty and all, like that type. Then it increases. Then it will become moderate. Then it becomes a breeze. Gale is one step below storm. Storm, and above the storm level will be like hurricane or tropical revolving storm. Now, tropical revolving storm is known by different names around the world. Australia, it is called Willy Willy. Americans call it hurricane. We call it a tropical revolving storm. And there are some more names you will find, but that is because nature is all over, so people have their own names. Now, what happens is sometimes during a rain, this is what you all have experienced. You get suddenly strong winds, then we say there are squalls with rain. So, wind is there, and wind will be always there. It creates resistance to the ship by two methods. One is the direct wind resistance to the accommodation block and any superstructure on ship. Other one is the waves which get created because of the wind energy gets converted, and you have got waves created. There are two types of waves. Okay, one is wind wave, other one is swell. Swell means wind waves got generated maybe hundreds of kilometers away. Now each wave, when you look at it at sea or any water, it is stored energy. This is where your physics comes in. Okay, this is stored energy, and it will need long time to get converted and dissipate. So the swell travels at times thousands of kilometers because that much of energy is available in the seawater. Okay, there are experiments to convert this into electrical energy and so on. Wind energy, we like to convert it by putting windmills and other things to convert it into electricity, which is easier to utilize. Ships, there are some experiments with some sort of a modern sails and all to utilize it to reduce the fuel consumption and all. But in commercial shipping, where the scheduling is very important part, it is not easy to utilize natural energies. You can use part of natural energy to save something, but you can't depend on it. It will be like sailing ships. Why sailing ships went out? They could not maintain the schedules. First thing, they could not guarantee deliveries. Okay, now the wind will be there. Now winds are created by variety of reasons. Like we get monsoon season, right? Southwest monsoon. We get northeast monsoon. Why? Because those are the climatic conditions. Remember what is climate? Weather for over a month. That is average weather. So climatic conditions, it happens during the sun's northern hemisphere or southern hemisphere and heating up and all. Like what happens is you get some high in Siberia somewhere, and that affects the southwest monsoon. So there are variety of things. So just remember there are many things. But wind is going to disturb us by direct and other action where it creates the waves which create resistance for us. So our speed gets affected. That is the most important. Speed gets affected straight away and we get bad weathers. Now then there are other, like one is the seasonal one. Like we know between say June to October you get southwesterly winds in Arabian Sea. Why? It is observed over thousands of years. Okay. Then you have got something else, sea breeze, land breeze. That happens every day. In all coastal areas, it happens every day. Daytime, land gets heated up. So, uh, air from the sea gets pulled on the land. Night time, relatively, land gets cooled down, cooler than the seawater. So there is higher pressure here, so it transfers something. Okay, they last only few hours and all, but those are land breezes and sea breezes. This also you have probably studied in school days. Now generally in meteorology you will learn that all the changes happen in the stratosphere and all that stuff you will to study. Right now we just stick to only one thing: there is wind which stores tremendous amount of energy, and that creates disturbances for ship by way of strong resistance on the aerodynamic part, as well as creation of waves. And in a long term view you get swell. Swell is the energy from the storm converted into the water based energy. Clear up to this? Yes, no?
Yes, sir.
No questions?
No, sir.
Okay, see, this is how the wind creates the waves. You can see here. See, so wave is created, it is breaking, because this breaking has got something to do with surface tension. This is where you see this part is blowing off. Here also it's blowing off with the wind. Here also you can see something is blowing off with the wind. So this is what happens. Now what happens? Ships are generally quite big, so it will have impact, but the smaller the ship, higher the impact. Oh, I'll tell you. Once we got delayed, once we got delayed at a short journey, which was supposed to be just 1 day sailing, we took 2 days of that. That was probably the one because what happened? Our ship was light. We were going to dry docks in Japan, and we sailed out of Korea. I think Korea and I think of Taiwan, somewhere we sailed out. And even though current was behind us, ship was very light. What happens is when you go to dry docks, you want minimum ballast and all because in the end there is economics involved anyway. So you try to keep it light. Now ship is light as it is. You can't take ballast in the hold because that ship had a heavy ballast in the hold. So you kept it was quite bad dance. We needed 24 hours extra. That was probably the worst one. And then you get bad weather storms and all. So that is different. Okay. Now impact on the ships is power driven ships because we are not really going for sailing. Some ships that I will tell you afterwards, okay? We will get a lot of time, so we'll keep it interesting. Toughest situation what I had was. Right now, let us do something here. Normally, power driven ships get affected, but not that severely. But major problem is windage area. How much area is exposed to the wind? Now, ordinary ships accommodation block is the only one, and whatever is the freeboard. Then container ships, there is a massive windage area because containers are all over deck. So it's a huge volume. So it has got large surface area and it creates bigger problem. Ro-ro ships, same like container ships, car carriers, livestock, all of them have got high freeboards. So the wind effect is very strong and it happens actually on car carriers and ro-ro ships. The ship is supposed to be like this, but wind is from this side, say, like this, okay? So they become actually like this because of wind. Because the whole surface area acts as a sail. So then we have to make the course corrections and all to make sure that you don't end up in a bad trouble. And again, what happens is the wind speed is never constant. So it will be like this. It will even cause some sort of a rolling. Now, wind is because we are looking at air on top surface of the earth. Same forces act, like whatever is acting, earth's rotational movement, etc., etc. They also act on water bodies. Oceans are denser media. Air is lighter media, but otherwise everything works same. As you go deeper, the pressure increases. Same thing happens with the air. The Coriolis force and other forces they act on both. But since you are linked with the mass, so the impact of certain things is less in air and certain things it is more in liquids. So ocean currents are formed in a similar manner. They are seasonal. Then there are permanent ones. Then there are seasonal, semi-seasonal, and different types. Okay, and they are affected by sometimes the wind direction remaining steady over something. Then a new current may get created, and those are temporary currents. Then another one is what we always assume is ocean currents are horizontal movements. It is true, but there are also vertical ocean currents, okay, which come up and then go on, then the bend because they can't go up in the air, and that is how the circulation starts. The whole thing is there is a circulation system of water. That is what we say ocean currents. From the, means if you really look at it, uh, just below 2 kilometers depth, there is a magna. Okay, Earth is that hot. Same thing happens on seabeds. Seabeds may have higher heat, deeper ones. So they heat up water, they send it up, then it bends, and then the ocean current starts. And this is something like a natural, like you must have heard about El Nino. Okay, Nino, करके we write Nino is the how they pronounce in South America. El Nino decides monsoons in India. So this is a complex system, but there is a current circulation. Now, what is it? There are two types of currents. One is a warm current, one is a cold current. You all have studied it in school. Right, wrong? Did you study or no in
Sir,
school?
actually, these El Nino and La Nino currents and these basic things were not for the people who come from science background, sir. It is there in 11th, 12th class humanities, sir, in geography.
Somewhere it is general knowledge. We're talking only
Yes,
general.
sir. In self-study, I have studied, sir, but not. It is not there in the class 12th or 11th course, sir.
No, not even seventh,
Apart
eighth
from that
standard
extra
somewhere.
study.
Seventh, eighth
No,
standard.
sir, 7th, 8th standard is mostly, sir, Indian geography. It is not of the world, sir. That is why
But
it is
currents
being
must
around.
be covered up somewhere, no?
Sir, as far as I remember, I haven't studied. Say current,
No,
I
that's
have
okay.
self-studied it
Don't worry.
for other
What
exams,
happened, no?
but not
Because
for
Sir, actually, the climate
academics.
chapter we have been taught in standard 6. So you can imagine the level of difficulty they have taught
no, no,
to
no,
us.
okay, I'm not saying anything. I'm just telling you it is a general knowledge about these currents and all. Now, what happens is like we studied in geography in school days. So, when joining sea life, it became quite easier because the gap was not that big, you know. Like we probably studied in 8th or ninth standard, and then next 5 years I was studying at sea. Then what happens is this is the horizontal movement of the water that is of interest to us, but it is actually a three dimensional. There is also vertical movement, and that is how the whole world's what you say marine life, like fish, everything is based on this circulation because it brings out the oxygen, it removes the uh, use the water, mixes it up, and so on. There are many things again that you will be studying separately. Okay, there is a full subject for you in second year, I think, third or fourth semester. Okay, there are certain golden rules you have to remember. One is warm current, one is cold current. Now what happens is there are localized currents, there are the standard circulation. The standard circulation in northern hemisphere is clockwise. Here. Okay. It goes clockwise. Like this, it will come here and come back. That means here. See. Comes down clockwise. There are reasons for it. Okay. Just don't get into it right now. Just remember it is there. Then southern hemisphere counterclockwise. Yeah, it's possible. That's what I'm saying now. A lot of stuff you have to just brush up. Yeah, see, many of you have done studies on things, extra reading, just improving general knowledge for competitive exams. Sometimes just genuine interest. Yeah, Peruvian current, that is Peruvian current. Here, somewhere here you will notice it, that current. If they notice it is around, the fishermen detect it basically. See, fishermen need to detect currents for simple reason. Certain currents will have more fish in it. Then the boundary areas, fish gets attracted and so on. So those ones keep more. What we think normally is, if we get any help, let's take it. If we don't get, forget it. So southern hemisphere counterclockwise. Now remember one thing, huh? From this Japan, this Australia age, to this US coast and South America, you are actually looking at 46% of the Earth's surface area. Okay, it's that big. When this picture is not showing you right, but if you have got a globe, you turn it around slowly and try to focus only on Pacific Ocean, is huge. That's why it decides what happens around the world in marine life, at least, and weathers, everything is controlled from there. Now here, North Atlantic Ocean, again clockwise circulation, anti-clockwise. Okay, here what happens is we don't have this thing. There are too many obstructions are there to have a natural currents, like what you have got here. 1, 2, 3, 4 areas. This is also this part. So 4 areas you have got a big one. Then you have got some currents in Antarctic areas and all. Now depends on the observation. But remember one thing: the temperature of the current is different from the temperature of the surrounding water. Always, whether it's cold or warm, both ways. Now, if it is warm current, there will be higher evaporation, so there will be higher humidity. And if you get cold wind, then it will freeze, you will get some sort of a fog. So, we monitor these temperatures, seawater temperature, we check the dew point temperature of the air to predict fogs. So, this is one of the impacts. Another one is one golden rule, okay? Golden rule to remember: where is warm current, where is a cold current. Okay, I'm talking in general. West coast of a continent, northern hemisphere or southern hemisphere. See, this is cold current. This is cold current. This is warm, 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 and this becomes cold. East coast of the continent. East coast of the continent will always have the warm current. That is, here you got a warm current. Here you got a warm current. Here you got a warm current. Here is a warm current. And this east coast again has got a warm current. So west coast is associated with cold currents of continents. East coast is with this. Okay. For us, we know current exists. It can give us extra speed. Means we can save some fuel if we are managing to get exact ETAs, everything. We'll save some fuel. Other one impact is it can create fog. Why? Because warm current are releasing more moisture in the air, and if you get a colder one and all, you can get fog. So that is another impact. Now, lot of funny things happen. Some of the currents are strong, and this close circulation. You get questions in what I'll say meteorology, all this on these ocean currents and all. Some of them are little tricky. Means, if suppose somebody throws one empty bottle here with a message, how will it reach Philippines? Sure, yeah, it is going to go travel all over, take a full circle, and when it comes here somewhere, it lands. So wow, once upon a time it used to be fun. People used to actually put messages in bottles and throw them in the sea, and then somebody used to find it sometimes after 1 year, 2 years, 5 years, 10 years. So it was just fun. Those days we had nothing else. Simple things were there. Okay, then currents have got names. What we will be always looking at it is normally this current, like this strong current. We use it because there is something called great circle track in navigation, which is the shortest distance. Right now, see, there is something going on, no? Discussion about all woman crew. याद में है? Going over North Pole. It is going on right.
Yes, sir. Yes, sir. Sir, recently,
Yeah,
the
correct.
pilots are from Indian Airlines, I guess. Or
Yeah,
some
yeah.
other, Air Asia, sorry, Air Asia.
Anyway, what happens is most of the flights pass over the polar regions. The reason is this distance. Okay, for example, Bangalore this distance going over the pole and coming down here, it is shortest route. This is not the shortest route. So this is what you will study in navigation and maps and projections and all. So this is shortest route going over. Okay. So just these are general points you remember. These are general points. Obviously, when you look at this is looking so big, no, it is not that big. Okay. Like Greenland is looking so big, but Greenland is not that big. It is because of projections you see like this. Okay. Now, the we search for currents. If I get it, very nice. If I don't get it, also I manage, because power driven ships don't get affected that badly. Then another golden rule is, for every current there is a counter current in opposite direction, and its strength may be weaker, much weaker. Like suppose if we take a scale of 10, the current has got the strength of 7. Very good. Counter current 1 maybe, and they are narrow. The like bandwidth type of the ocean current will be maybe few nautical miles. Counter current may be a strip, but for every current there is a counter current in opposite direction, and that temperature will be different than the current. So when we search for these currents, no, sometimes we look at temperature, and we know when we enter a current because temperature has changed. See what temperature. Like strong current can give you speed by 4 knots. Okay, that is generally where you will find the strong currents. I'll show you. This Gulf Stream, if you are coming from say Houston area and coming to Miami is here, and you are going here, and this is the shortest route in any case. So we love it. From here onwards, from this point onwards, the Gulf Stream gives you about near Miami, you get 4 knot speed extra, and then it starts becoming slower by the time it reaches here. If you are going to UK, because basically you come up to here and then you move up. So there you may get average, you will say that okay, I got 1 knot extra speed, means I saved so much of fuel. Then this is another strong one. Okay, from Taiwan, here it starts from here. Kuroshio, that is black current of Japan. Kuroshio means black current. It's very strong. Again, it will be about 4 knots here, and then it goes up. And Pacific also, what happens is, if you are coming even to Panama Canal, this is the shortest route. So you get advantage of this current. Those are the major currents what you follow. Then these are relatively less. And another one, this equatorial, north equatorial current, south equatorial current, and counter current in the middle. This one, if you are sailing on these routes, we carefully check and try to stay in the current, because you can get as much as 3 knots, 3.5 knots, depending on the season and weather, extra speed. So you save fuel, but within limitations, because in the end, what you want is the scheduling. You don't go for current. It had happened once. Okay, I must tell you one story. Okay, what happened? We were somewhere here in Japan. Okay, let me see if I can give you a little better idea of it. Okay, now it is little bit clearer. Somewhere here I went to dry docks. Somewhere here. Okay, we came out of dry docks. And we were supposed to go to here, Chiba, that's Tokyo Bay, Tokyo. We came out, now we had to sail here. And then we started sailing, and I got the message from agent that berthing is delayed. You will be berthing after 3 days or 4 days, whatever was the delay for. It was Saturday, Sunday, and couple of holidays, something like that. So when I was here, I stopped the ship's engine. जल्दी जाके करेगा क्या? I tried to ask him, can we come inside and anchor? He said no. You will have to stay out at sea only. So we stopped here, and the current pushed us approximately 260 or 70 nautical miles. Current pushed us, and that was almost like 1 day's sailing on that ship. So we saved probably around 30 metric tons of fuel oil, and we reached there without any really using engine. Now that sort of a power current can have. Now, not to be mixed up, like I told you, tidal stream are also very strong, but tidal streams are different than currents. In physics, you probably will say that okay, both are current because there is a movement of bodily movement of the water. But currents are different, and tidal streams are different. Tidal streams are temporary in nature; they last only about 6 hours, and then they reverse the direction. Yeah, it is huge distance. But that's one thing, it is luck, one of the things, We were just waiting and current took us there. That's it. No big deal. This is what, if you enjoy it, you find variety of instances, how it happens. And at sea, you get these periods, it's not always busy, busy, busy. Sometimes you have to wait. Why? There is a holiday there. So you wait 5 days at anchorage. Once I was in Australia here, somewhere here. We went alongside, and Australians are very fond of going on strikes. Australia is worse than India when it comes to labor unrest. Went on strike. Nice port, no cargo work. And they said also that 5 days we will not be working. Fantastic. We were alongside. We had good stay in port. So that is luck. Okay. So you understood the difference is there between tidal streams and ocean currents. Yeah, ship doesn't have brakes. The braking is go reverse. Put the force in opposite direction, and then it will put some sort of a brake and stop. But see, ship is tied up only in the port or in a port area, anchorage or alongside. Other than that, ship is always free to move. Either weather will move it or you move it with engines. One of the two. But it is not tied down. That is what we use the term underway. Means she is floating and she can move anyway. Okay, so clear about the clear on the currents.
Yes, sir.
Okay, now this is the last part we will, and then we will stop. Areas of bad weather. Some areas have been identified because of local conditions, seasonal things, everything. The weather is 90% time is bad, and it's a localized phenomenon. It is not like any special reason or something, but that localized area, somehow the environment is balanced in such a way that area is always turbulent. So these are some of them: Bay of Biscay, Gulf of Alaska, Drake Passage, Cape of Good Hope, Bass Strait. Now I will show you this Bay of Biscay. This is Bay of Biscay, north of Spain. North of Spain, between say Spain and Portugal, there is the Bay of Biscay. Then Gulf of Alaska, Drake Passage. Okay, here. Okay, these areas. This one. Okay, that is bad area. North of Aleutian Islands. Then Drake Passage or Cape Horn, that is this South America's tip. Cape of Good Hope here. Bass Strait here. These areas, the 90-95% probability is it is bad. Okay, that's why we say these areas are associated with bad weather. So, what is the impact? We know ship is going to get slowed down there. That is what we assume. We will try to avoid it if it is possible. Avoid the area. You know that lafda hota hai. Why you want to go from there? That is how we look ashore also. No? वो लफड़े का area avoid it. So same way we say that avoid it, but it's not always possible. Here, in case you can't avoid it, you go through it. But when I'm going to go through it, I'm going to do my calculations and say I will be losing say 10 hours here extra. So I adjust my ETA accordingly to tell people what time I'm going to arrive in the next port. Because I may lose 10 hours speed here, so which I will recover partly maybe. So I adjust it and say, okay, I will reach at this time. That is the only impact you have got of the bad weather. Time zones we will be doing next time. It has got a lot of interesting stuff in time zone. Okay, especially nice stories for parties. Okay, now tell me any questions? Any questions? One
No,
question.
sir.
No, sir. Coriolis, Coriolis effect is Earth is rotating. Okay, it has got mass. There is a force gets created. Means in simple words. Okay, in simple words, is if I'm going from A to B, what you will say, join it and go straight. But if there is mass involved, the reaction between these, the forces, that is Coriolis force, is because of Earth's rotation. I can't go straight. I have to go at an angle, so my resultant direction will be straight. That is the force. You will be studying it in meteorology. This in more in details. That is Coriolis force. That means I have to go at angle. I can't go straight. If I try to go straight, I will go at an angle. That is exactly what happens, Coriolis effect. And it reacts with the air, it reacts with water both.